My gene cell. Again. My gene cell question is, can I build a successfully functional hovercraft? This is a hover. They are amphibious vehicles, which means they can go on land and water. They are also all-terrain. My first subtopic is, how does a hovercraft work? My sources are the internet and the book How to Build a Hovercraft. The hovercraft uses compressed air to hover just slightly above the ground. It pushes air out the bottom, causing lift. This creates low friction. What is friction? Friction is when two surfaces' asperities rub together and make the two surfaces hard to move. What are asperities? Asperities are the small bumps and ridges that make rough things rough. But the skirt does drag along the ground. The skirt does have low friction. Low friction hovercrafts are a great science breakthrough and are used in military, transportation, the nice rescue teams, and recreation. My second subtopic is, what materials would work best for building a hover? My source is my experiments. There are many different ways to make a hover. I will be trying two: the tabletop hovercraft and the teardrop hover. Here are some videos. This is the tabletop hovercraft experiment, and I will review and test it.
Who let the dogs out? 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 When the party was nice, the party was bumping. Yippee-yi-yo. And everybody having a ball. Yippee-yi-yo. I tell all the fellas, start the name calling. Yippee-yi-yo. And the girls, they all respond to the code. On the Bulldog Showdown. Who let the dogs out? Who let the dogs out?
So here we are with my hovercraft. The materials I have used are a bottle, which the top can be seen here, a CD, and a balloon, the cap, and I've also used a pin and glue. So the CD here will be dragging slightly just on the ground, but it'll be low friction, as I talked about earlier, because of the amount of asperities on the CD. Wow, look how thin that is. Hold on. So it will be dragging slightly on the ground, but you never know. It's an experiment. It could like fly up. You never know because you're doing an experiment. So the CD should have low friction when it drags, thanks to having not many asperities, which I have defined in subtopic 1, but in case you can't remember. Asperities are the small bumps and ridges that makes rough things rough.
Turn down for what?
Alright, so now I'm going to ask now let's look at some questions about how the hovercraft ended up working. So, first of all, did it really hover at all? It hovered, yeah. How much friction remained? Not much. Well, I mean, it was a bit, but not much still. It was very steady, actually. It wasn't hovering very high, and it had no load, so I don't think it cared much. How did it hover high? Not that high. Alright. So, yeah. materials I have used in my hairdryer hovercraft is 3 paper plates, duct tape, and a pencil, and also, of course, the hair dryer. So this, just like in my other experiment, should be able to have low friction. But once again, the bottom part, the 3 paper plates, will be dragging slightly along the ground. They also have low friction because of not many asparagus, and should be able to pretty much glide on a cushion of air. So I'm about to test it and see how it goes. Let's review how the hovercraft worked. First of all, did it actually hover at all? No, it did not. There was tons of friction remaining. Well, it was steady because it was sitting there. What can it hold? Nobody knows. Definitely did not hover high. And those are the results for the hairdryer hovercraft. Work. Tabletop hovercraft work, but not the hairdryer. I think that this might be because of the weight of the hairdryer. This led me to ask, can I build a bigger and better hovercraft? I will be building the leaf blower hovercraft. My source is the book, How to Build a Hovercraft.
Everything is awesome. Everything is cool when you're part of a team. Everything is awesome when we live in our dream. Everything is better when we stick together. Side by side, you and I gonna win forever. Let's party forever. We're the same, I'm like you, you're like me. We're all working in harmony. Everything is awesome. Everything is cool when you're part of a team.
So let's see how it worked. So first of all, did it hover? Yes, it did. And then how much friction remained? Well, definitely not much. It went very fast. And I think it really was steady. Like, I didn't see it like going off at all. It definitely was steady. It could hold my weight, and that's pretty heavy. So that too, yeah. It didn't really. It kind of hovered high actually. If you could see in the video. And well, yeah. So, I learned that you don't always get it right on the first try. I learned there are different ways to do some things, and I learned that I can make a bigger and better hovercraft. Now, the answer to my question is yes. As you saw in the video 8 slides ago, I made a hovercraft, and it hovered. Now, after I recorded that video, I modified the hovercraft. One, which includes, but is not limited to, making it hover higher. I am still fascinated by hovercrafts. Why? Hovercrafts can hover, travel at high speeds, and go on almost any terrain. And in addition to being all-terrain, hovercrafts are fast. The top hovercraft speed, according to Guinness World Records, is 137.4 kilometers per hour. That's 74.19 knots. 74.19 knots is about 3 times the speed of the Titanic. And we all know the story of how it went too fast. Imagine that, but 3 times faster. Whoosh. The name of the man who set this record is named Bob Wind. He set this record in his Universal UH-19P hovercraft, which he called the Jenny 2. Now if you notice what Bob is saying, hovercrafts can be small, but they can also be like this. The end.